Okay, good evening or afternoon. Today's lesson we're going to be talking about linear functions and direct variation. Woohoo! Linear functions should be review. You should remember y equals mx plus b. M represents the slope. Okay, and b represents the y-intercept. Okay, so we have y equals 3x minus 1 up here, but that is clearly not the picture for this graph. So we need to cross that out because that must have been a typo. That needs to say y equals 2x. All right. The slope of y equals 2x is 2, and the y-intercept is 0. Okay? Is it a function? Does it pass the vertical line test? Yes. Horizontal line test. That's new. But if it follows the same rules as a vertical line test, that means that if you were to draw a line through it going horizontally, would it only touch the graph in one spot? And that is true. So yes, it passes a horizontal line test, and that actually helps us determine if something is called one-to-one, and that gets explained a little bit better down below. Now this is a line, it's an oblique line, and the domain is going to be all reals. Remember, for the domain, you're looking, is there any restriction on x? I think I could enter any number I want in for x, so the domain is all reals. And then any number that comes out after I substitute in a value for x, what kinds of numbers are coming out? They are the range. Those are also all reals. That's going to happen for oblique lines every single time for the domain and the range. Next, we have a definition for one-to-one. A function f is one-to-one if no two ordered pairs have the same second element . In other words, no y values or y coordinates repeat. Okay, so for every y there's one and only one x. We can test the graph of a function to determine if it's one-to-one by the horizontal line test, or the HLT. Making me hungry, making me think of BLTs. All right, so determine if the following are one-to-one. Let's say we actually have a horizontal line like y equals 4. That is not one-to-one. Every y coordinate is 4. 1, 4, 2, 4, 0, 4. Number 2, let's say we have a parabola. Y equals x squared. Nope, that is not going to pass a horizontal line test. These two coordinates here could both be 2. Okay, something comma 2, something comma 2. Cannot have repeating y's, so no, this one is not one-to-one either. But if I take like y equals the square root of x, then yes, now that is one-to-one. It only touches in one spot, not in two. This one is every single spot gets touched. All right, so every non-constant, okay, this is a non-constant, oblique, linear is one-to-one and onto. So, for example, there is an oblique, non-constant linear. It is one-to-one and onto. Remember, onto is talking about the fact that you would use every element in the range. And it's all reals. You would use all the the elements of the range for any oblique linear line. So always they are one-to-one and onto. Direct variation is next. Direct variation is your proportions that you may have learned in middle school. When the ratio meaning fraction, of two variables is a constant, so constants never change, we say that the variables are directly proportional. Or that the variables vary directly. So an example is distance equals rate times time. D equals RT is distance equals rate times time. So if the rate is 55 miles per hour and you remain constant at that rate, okay, distance divided by time equals 55. If you just solved for D here, you solved for the 55, and you divided both sides by T, you would get D over T equals 55. D and T vary directly. If you were to actually graph a direct variation graph, okay, the graph is always linear. So it's a line, and it always goes through the origin. Okay, it's oblique also. So you can't say x equals 0 and y equals 0. Okay, so they have to be linear, oblique, slanted lines, and they go through the origin, which is 0, 0. Every direct variation of two variables is a linear function. No repeating x-coordinates. All linear oblique lines are functions. That is one-to-one. Going to pass a HLT and a VLT. VLT for the linear function, HLT for the one-to-one. Okay, so some examples. Graph each of the following. Determine if it is a direct variation. Determine if the function is one-to-one. So y equals 5x should go right through the origin because it'd be like plus 0, and then up 5 and over 1 for the slope. Remember, you do rise over run, so 5 over 1, rise over run. And so 2 points determine a line, so if we were to draw that, I'm doing a sketch, okay? It is a oblique linear that goes through the origin. So, yes, it is a direct variation. It can also be written as y over x equals 5, which goes back to the definition when the ratio of two variables is a constant. And it is 5. Is it one-to-one? Yes. Is it a function? Yes. Okay, y equals 7 over x. Well, what that means here is that x cannot be 0. So what that graph is going to look like is like this. And I'm going to take a second to show you, because you've got what's known as an asymptote, undefined value at x equals 0, and an undefined value at y equals 0. We denote those with dotted lines. They're called asymptotes. and it's where the relation's undefined. Okay, so just to verify that real quickly, y equals 7 over x, waiting. Thank you for your patience. All right. Y equals 7 over x. I always go to zoom 6. You can see what I was talking about. Okay, and it's got an error in the table. So, is it a direct variation? No, it is not linear. And it's not going through the origin. It has to be both of those things. Is it one-to-one? Does it pass a horizontal line test? Yes, it does. I know it might not look like it does, but these lines, they do not ever become vertical or horizontal. They get closer and closer and closer to the dotted undefined line, but never touch it. It's an interesting concept, but it never touches the line, and it just inches in closer and closer. All right, now on to number 3. Now we have, again, starting at the origin, and then the rise is 1, the run is 4. So now it's going to be just a little less steep. And yes, that's a direct variation. It's linear. It's going through the origin. Yes, it is one-to-one. Next, y equals the square root of x minus 3. If you graph that, it's going to be over here at 3, 0, and it kind of goes off in that direction. So y equals the square root of x minus 3. And I need to delete and delete. There we go. And you can see the graph, and you can see that there's no points before x equals 3. They give you undefined. So it's not a direct variation. It's not linear. But it is one-to-one. It passes that horizontal line test. And then y over x equals 4 is the definition. This equation, if I solved it for y, would be y equals 4 times x if you just cross multiply. So we're going to rise 4 and run 1. So yes and yes. Okay, another example. Mark can type 60 words per minute. Write a function that shows the relationship between words typed W and the number of minutes M. So if you took 60 words per minute, then I would think you would take your words typed W divided by your minutes equals 60. Or the words typed equals 60 words per minute. Okay, and I'll write that out, 60 words per minute, that's like your rate, times M, which is your number of minutes. And so units are supposed to cancel, and they do, so words equals 60 words. So W equals 60M, or W over M equals 60. Okay? So is the function one-to-one? Well, it is the definition of the direct variation. We've got the ratio of two variables equals a constant. Those were all going through the origin and linear, so yes, it would have no repeating y coordinates. If Mark types for no more than 2 hours, what are the domain and range of the function? Well, our equation is in terms of minutes, so we have to convert 2 hours to 120 minutes, first of all. And so then if he's typing for no more than 2 hours, the minutes, if you take a look at the equation from up above, W equals 60m, that's almost like Y equals 60x. So our domain is the possible minutes. Well, he could work 0 minutes up to 120 minutes because it said no more than. So the domain would be 0 is less than or equal to m, which stands for minutes, less than or equal to 120. Now, if we put 120 in for x, okay, so if we do y equals 60 times 120, which is our maximum value from our domain, then our y, which is actually our words, would be 720. So the maximum amount of words he could do would be, if we did 0 minutes, you would get 0 words. But when you do 120 minutes, you get 720 words. So our range is going to go from 0 to 720. And it's going to be the y coordinate, which was the w. Okay, that concludes it. However, there's the next page actually has a calculator activity. I'm going to continue on with this, but you can be done with the lesson as the calculator activity is just optional, but it is interesting. So I'd love to have you stay with me if you would like. Compare each set of graphs and form a hypothesis and or conclusion based on the movement from y1 to y2 and y3. Okay, so if we take y1, if we take all of those and we do plus 3 and then minus 3, first of all, they're all parallel because they all have the same slope. And if we graph them, they have different intercepts. So one's at 3, one's at 0, this is going to be x, y, and one is at -3. So they all have the same slope, so they go up 2 over 1. So this graph kind of looks like this, up 2 over 1. This graph looks like this, and up 2 over 1. Okay, so if we take y equals 2x and then we compare it to y equals, this one was 2x plus 3 and this one was 2x minus 3, it looks like it goes up and down. So your conclusion should be that if you have y equals mx plus b, then that goes up b. But if you have y equals mx minus b, then that goes down b. And this is going to apply to other things besides linear functions. All right, the next one is y equals 2 times x. 2 times x plus 3, 2 times x minus 3. If you graph those, then what happens with them is they appear to move. So here's y equals over 2 up 1. Here's y equals 2x. And if you graph y equals 2x plus 6, okay, it actually goes through the coordinate -3, 0. So there's 2 times x plus 3, and if you graph the other one, which becomes 2x minus 6, it actually goes through the on the x-axis 3, 0. So what we say is happening, so this one is 2 times x plus 3, and this one was 2 times x minus 3. So what we say is happening here is it's moving left and right, the amount. So the conclusion is if you have y equals a times x plus h, that moves to the left, just like 2 times x plus 3 did. And if you have y equals a times x minus h, that moves to the right. So left h and right h. Okay? Next, and you could grab all these in your calculator as well and compare them. 2x, 4x, 6x, and 8x. Well, what happens here, if you start with 2x, it's up 2 over 1, okay? And then if we then go to 4x, that's up 4 over 1. And then 6 is 1, 2, 3, 4, 5, 6 over 1. What happens there? It starts to get steeper, almost like straighter. So what we say happens there is y equals ax, and a is larger than 1. As a increases, the line gets steeper, and that will happen with other functions as well. And then a is decreasing for the next one, so y equals 2x is up 2 over 1. So there's y equals 2x. And then y equals x is now going the other direction, up 1 over 1, so it's a little less steep. So there's y equals x. And then y equals 1/2 x is going up 1 over 2. And so it looks like it's going to get more horizontal. And what happens with that is that a is now decreasing. So as a decreases, so it's y equals ax. As a decreases, the graph gets less steep. Almost looking horizontal-like. So let me just go back up here for a second. This one was y equals 2x. This one was y equals 4x. And this next one was y equals 6x. Okay. And I think that's it. All right. Well, have a good night.